For these two questions, we're meant to rewrite these expressions as a perfect square plus something else. So for instance, if I had x plus maybe 1 squared plus 2, this is a square, perfect square, this x plus 1 plus 2, and I could rewrite that into x squared plus 2x plus 1 plus 2, which is the same as x squared plus 2x plus 3. So instead of going this way, which we're all pretty comfortable with probably, it's going the other way, turning a polynomial into a perfect square plus something else. All right, so let's do that with this one first. I'm going to take this constant and I'm going to leave it out, and I'm going to say this is x squared plus 2x plus something plus 8. Now, what do I need to make this a perfect square? Well, there are two ways to do about it. You could just kind of think about this and say, okay, well, what perfect square looks like this? You might see, well, it's this x squared plus 1 over here. But you could also take this middle number and divide by 2. Because whenever you square it out, you're going to get 2 of those terms. In x plus 1 squared, I'm going to have 1x when I multiply x times 1, and 1x when I multiply 1 times x. So you could take this number and divide by 2. So I'm going to take 2 and divide by 2, and I'm going to get 1. And I know that this is the same as x plus 1 squared. But when I added that 1, I changed it. So I also need to subtract 1. So there I haven't changed it at all. I added 1 and subtracted 1. But this right here becomes x plus 1. This was plus 8, but now it's just plus 7. And now I've completed the square. I have written this as a perfect square plus some constant. Okay, let's try the same thing on this next one. Here there's this added detail of this 3 sitting right here. I'm still going to leave that plus 8 out. So I'm going to think about this as 3 times x squared minus, if I take a 3 out of this 18x, I get a 6x, and then I'll leave a big space, and I still have that plus 8. And I would love whatever this is to make this thing a perfect square. So again, I'm going to divide the 6 by 2, and I'll get a 3, and I know that this term should be 3, and I'm going to square it. So over here it was 1 squared, here it's going to be 3 squared, and I'll have a 9. And I look at that and I think, okay, well, this is the same as 3 times, well, this thing right here is x minus 3 squared. But I added on a 9 here, so I have to subtract off the same thing. But what did I really add on? It wasn't just a 9, it was a 3 times 9, right? So I really added on 27, because that 3 is multiplying by that 9 as well. So I have to subtract off the whole 27, the whole 3 times 9. My constant then is now 8 minus 27, which is minus 19. So the goal with completing the square is to be able to write this expression as something squared plus some constant. And sometimes you pull a constant out, like in the example B.